Good evening, everybody. I hope everyone had a pleasant Diwali and everyone has enjoyed their holiday in past 15 days or so. And we all, it is all over the country, the celebration happens. So yeah, I believe from north to east and west to south, everyone was busy. Myself, Kshitija Poddar, I have been working with IC from April, and we have started this e-platform for making people understand that how things are changing and how can we exchange the knowledge with each other, and how we can grow this knowledge amongst our industry itself. So, as everyone is aware what IC Eventus is all about, IC we'll be having our upcoming shows coming in this December, which is going to happen in Nairobi. And then next year, we will be having our show at Delhi, which is at Yashobhumi. We'll be calling this IC Global because global companies coming in, international companies coming in, domestic companies coming in. So, we are making it and taking it global. So, I hope everyone is very well aware with the dates of our exhibition, which is in this December for Nairobi, 2nd, 3rd, and 4th of December. And in next year for India, which is IC Global, we will be doing 3rd, 4th, and 5th of December 2026. So as a part of this vision, we are calling many companies who are already on board with IC Global 2026. We are having an session today with JL Seagull. I am glad to introduce Mr. Selvam today, who is being a pioneer in the industry, who is a veteran in industry, I would say. And he's been doing a lot of work to help around people, teaching teaching his generation to our generation, and sharing his knowledge, what he has within himself, giving it to the world. He's been doing the social work. Along with that, he is also doing so many things which is helping. He is being an alumni for college in Tamil Nadu. From his batch till today's batch, to the young generation, he has been having these alumni sessions in the part and regions of the country where with the entrepreneurs of business, and not only elevator industry, from his college, a different subject people who come together and share their knowledge. That's how he's growing and making the generations knowledgeable around the world as well. So I introduce Selvam sir on board, and I shall hand it over to you. Please note, we will be having a question answer session once once Selvam sir's presentation is over, and we will be taking the questions, and I will ask Selvam sir, and he will answer for those questions. Please be patient during the presentation. Thank you. I hope you enjoy. Selvam sir, over to you, please.
Thank you. Thank you, Sujja.
Thank you.
Good evening and welcome all. Thanks for your interest on this topic. It's not a very popular topic, but nevertheless, it's an important topic. So this session, you may be aware, it will be around 1.5 hours session, mostly on technical side. And last 15 minutes, there will be a question and answer session. I will try to cover and share my knowledge, whatever I have acquired. I am also an elevator engineer. I was working with Kone Elevators for about 17 years, 2 times. Last I was working with the global R&D. During my stay, I used to do the product on technical side, visiting various sites, and product proving and training and product development. Lastly, for global R&D, I was in charge with the PCB Reliability Center also. So I have used this elevator vibration analyzer, and I started my business in 2009. The company name is JL Seagull Power Product. Last 15 years, I'm serving elevator industry in India, mostly, also Middle East, Sri Lanka, and Bangladesh. I represent 3 companies, one international companies. For the elevator vibration analyzer, I'm representing a company called PMT, Physical Measurement Technologies Incorporation, USA. Last 15 years, I'm providing sales, service, support, and calibration, and also training for this product. And second one is the rope tension gauge from a company called Go UK. Third one is last 5-6 years I'm selling one product called pinch force measurement tool used for measuring the force on the doors in elevators. It's for a German company called Drive Test Germany. So these three companies I represent. With this, I will complete my introduction, and then I will start the session. It's a formal session. Once again, I will share the slides. Second.
Go on the share button below, sir. Did you find the
Yeah,
button?
yeah.
Yes.
But the
Yes.
window I have to open it. The
Yes.
slides. That 1 second.
No problem.
Sorry for the delay. 1 second.
No problem, Selvam, sir. You can please find the.
Yeah, slide is there, but it is not sharing on the thing.
Share the screen which we have done previously.
Yeah, 1 second.
No problem. No problem.
Okay. Do you get the screen?
Yes, we can see the screen, sir.
Okay. Good evening once again. See, my company is called Seagull Power Product. I represent PMT from USA for this elevator ride quality related products. This session I will cover ride quality measurement on the elevators as well as escalators, mostly on elevators. And the topic of the session is the ride quality and safety measurements in elevator and escalators. Safety measurement involves in escalator related gap measurement as well as speed evaluation. So as I said, I represent three companies: PMT USA, Drusco UK, Drive Test Germany. Last 15 years, I am supplying this product to many leading companies in India and abroad. I have listed out the major clients and not many regional players. I have not listed it, but they are also very important. I have, just for the sake of giving some overview, I have listed out this. The session will be in three parts. First part will be the basic side of ride quality measurement related to the standards. It's about half an hour. Next half an hour, I will be dealing with how to measure the ride quality and how to do the analysis and interpretation on ride quality. The third and last half an hour session or 20 minutes could be escalator ride quality measurement and escalator skirt gap measurement, escalator stopping distance, speed measurement, closing door force measurement, and rope tension adjustment tool. Say, when in elevator industry, I joined in 1986 after my post graduation. Till for about 10 years, when I worked 6-7 years I was working with the Kone elevator. I was doing commissioning of 2.5 meter per second elevator in Chennai, Mumbai, and Delhi those days. Those days, ride quality we measured, but not with using any such tools. So why this ride quality is important? Basically, when you do the ride quality measurement after installation and commissioning, the ride quality performance will be influenced by all three parameters, like basically design of the equipment and how it is installed stage wise, how the guide rails are installed properly, how ropes are laid properly, and machine how it is fixed properly. Those things can influence. And third one is that during the service usage, how you are maintaining, because it's a lot of rotating element involved. So there is a, like doors, there is a lot of wear and tear will be there. Machinery, gearbox, so many rope, it can wear and tear. So all these three aspects, design of the equipment, installation of the equipment, and how we maintain, all three are going to get affected. It is going to work in an integrated manner. So by measuring the evaluating the right quality, we can improve all three areas. For example, R&D, when they design any new electronics or any new component, one of the components in the elevator hoisting system, so they can independently study the influence of right quality, say you drive or any new type of rope you are designing or any new machinery you are going to try it out. So in R&D level, we can decide the right quality about the design aspect, as well as in during installation and maintenance. So all these three departments can use nowadays. I mean, so far what I have seen, mostly R&D department they may be using it, and installation mostly leading companies, and wherever government contracts are there, metro rail projects are there, it will be covered in the contract. There they will measure after installation the performance of the ride quality. Maintenance side, generally it is, I have not seen people follow ride quality measurement for during the usage of the equipment. Easily we have a elevator for 20-25 years, but this tool is very rarely used for the service and maintenance purpose. By this type of session can help create the importance for using ride quality measurement for maintenance area also. Also, since when we say a product, elevator product is not completely manufactured in the factory. Component wise, we will purchase from many vendors and assembled at site only. So it is becoming a product in the site only. So many components are interconnected. The fixing of each and every component plays a important role, accuracy and the quality of the component. So it becomes a product only at the site. So supposing one motor we are purchased, and the motor is having a problem, we may not know after installation and commissioning only. When we want to hand over, that time we will face a problem in vibration. Then we start troubleshooting. It may take a lot of time. By trial and error method we will be doing it. So it is going to cost a lot of time. So it is going to cost time, cost and money. So that's the purpose of doing the right quality measurement. As I explained, those days from 80s and 90s, early 90s, uh, we right quality is more on subjective. When you want to see whether the particular elevator is having good smooth ride, some experienced expert has to travel inside the elevator, and based on his experience he can ride and feel and listen, and he'll note down the sounds occurring in various points along the hoistway, and any jerk any quacking occurs, these points can be observed, and they will suggest how to improve all these things. It's more of a individual's expertise. So it is a very subjective item, and based on his experience, someone can solve the problem, or it can continue to try. That's all. So it's going to be a time-consuming affair. Also, it is the drawback of this method is it cannot be repeatable. The same person yesterday when he was traveling, he may found it okay. Today when he is traveling, he may find something abnormal. So it depends, depending on his mindset at that point of time, it may be different. And also it says non-repeatable, and also non-calibrated means there is no reference. Based on his like when you do a cooking, somebody can say it is very tasty, somebody say it is not so much tasty. It depends on the individual, and so also psychological. uh, so very based on these three aspects, it's a very subjective, very qualitative, and based on the expertise with that thing. It is that way. It is not a democratic type. Only a person with more than 10 years, 5 years experience only will be able to say it's okay or not okay. But if he says okay, customer may not say okay, consultant may not say okay. So it's a very subjective one. So after this right quality measurement method discussion started in 1995 onwards, I think 1993 or something. In Australia, I think Otis started this thinking to design a instrument for measuring the right quality. So, and a group of people, experts joined together, they formulated, they tried various methods and formulated the standard and design and equipment. Our company, principal company, Physical Measurement Technologies, was involved at the stage of 1995. This product was designed in the president is a geophysicist, more of a science background, and he was doing something for the mines industry, some vibration measuring equipment. I think some people from Otis approached him to design a product for measuring the vibration in elevator. So in 1995, this product was for maybe 1 or 2 years, they designed, tested, and perfected it and formulated the standard. They started in introducing from 1995. Even now, Otis was using this product for even 1990. Sometimes we get instrument for calibration even 1998, 1997 and all. So quite a long period there. Otis and many other companies are using, the leading companies. So now we'll come to the basics. Now we have seen what was the right quality measurement method, what is the new type of method they were formulated in 1995. And the basics of the right quality, see the standards originally till last year or something, the standard number is called elevator right quality and escalator right quality. Number is 18 ISO 18738 part 1 and part 2. Part 1 for elevator, part 2 for escalator. Now recently they changed the name, the number. They made some corrections in the error, not on the right quality side, some some more of a I understand from my principle, it's more of a wording change or cosmetic change. Its number is called ISO 8100 34 2021, and it is going review and all every some years. And for escalator, the number is different slightly, but essentially the 18738 all aspects are adopted in the same ISO 8100 also. So it was one and the same almost in practical speaking. See, this ISO 8100 or 18738 was formulated based on three aspects, three standards. The first one is called ISO 2631. It is called human response to vibration. See, we are here. This instrument is meant for measuring the vibration inside an elevator. Uh, Vibration measurement is applicable for many products, like for example, generators, alternators, or any rotating element, big machinery. Vibration use it is occurring. There are different class of vibration measuring instrument for such machines. For the elevator industry, there is a difference. Here also, we are measuring the vibration, but then we are measuring the vibration focused on a particular area. That means which is sensitive to the human beings, because it is for the user only. Vibration, just somebody is not going to use. For example, goods lift or some transport lifts, nobody will be bothered. But but people are going to use the elevator. If there is a jerk or vibration, they will be they will feel unpleasant. So it is meant for the human sensitivity. So they formulated a standard called ISO 2631 for the human response to vibration. For example, if your body is excited by some force, for example, inside the car is vibrating. A person standing on the elevator car, he is also will be vibrating at some frequency. That means the source exciting frequency is something, and the body can respond for that frequency. So by scientifically speaking, the response frequency is shown in this diagram. It's a representative diagram. You see different parts of the body respond with the different frequency level. Uh, for example, head 25 hertz, legs 2 hertz, like that. So from 2 to 20 hertz, 30 hertz, it is going to respond. So beyond that, any more than 100 hertz, for example, our body cannot sense. It is like we are familiar with the infrared light curtain in elevators. It is meant for whenever somebody is entering the elevator door, if we put a hand, it will sense and open the door. Though we are not able to see the infrared, still it is present. Because of that only the beam is obstructed and controller is opening the door. So though we are not able to see that, but still it is present. Like that, beyond 100 hertz frequency, vibration may be there, but our body cannot sense beyond 100 hertz, and mostly lesser frequency only we can sense. So the 2631 formulated based on this fundamental principle of human body sensitivity. So it is used for evaluating the comfort level. First, whether the traveling person, whether he feels comfortable. Suppose one person, attender, is sitting, is doing this keep on for many months, many years. Definitely his health is going to get affected. So that may not be worried, because attender is a poor chap, he may not be worried. But it is not a comfort level, it is more on the health aspects. So it is this standard will help in understanding the various frequencies involved, and how to remove that beyond which are very sensitive to our body. What are the different frequencies? For example, when the elevator is running in the up direction from ground floor to topmost floor, vibration can occur in three directional, like horizontal direction, from door to front side, from the door side, front and back. Likewise, for the horizontal vibration, lateral quacking, or sideways, like guide rail to guide rail, that type of movement. That's. And the third one is the vertical vibration, when it moves up. The horizontal vibration, it is axis is called X and Y. X is represented for the front and back vibration. Y is meant for the side measurement, side wave movement. Sorry. Z is for the vertical vibration. So our body, this graph, whatever you are seeing, this graph is representing our body response for different frequency of external force. If some external force is applied on our body and different frequencies, our body can respond at this level. For example, 0.1, 0.2 hertz, it's very, very, very poor. We may not be able to sense properly. And when the frequency increasing up to 10 hertz, the sensitivity is increasing. At it attains a peak. That means at 10 hertz vertical vibration, we will be able to sense the vibration properly. Less than that, even if the amplitude of the vibration is high, our body cannot respond. Likewise, beyond 10 hertz, the sensitivity again reduces. So mostly around 10 hertz, whichever, supposing an object, any rotating element, rotating at 10 hertz, that means we will be able, it will be very pronounced, our feeling. Also, likewise for the horizontal side, the frequency versus that amplitude response curve, if you see, it is the major sensitivity occurs at 1 hertz. Beyond that, it is keep on reducing, drooping, and also less than 1 hertz less. So this instrument, when they formulated a standard based on the ISO 2631, our body cannot definitely sense more than 100 hertz. So they designed they formulated the guideline, the construction of the equipment, so that it can capture maximum 100 hertz, 0 to 100 hertz only. Beyond 100 hertz, the equipment will not capture the signal, because if you have a broad spectrum of the signal, then you have to have a very costly equipment. For example, I have tried to sell one vibration equipment for the alternator and all. The cost of the equipment was around 50-60 lakhs. So in elevator industry, such cost cannot be occurring, because there it is very sensitive. Supposing the vibration in a machinery in a very big alternator, if it is not coupled properly, after some time the coupling will break. It will cause a lot of damage and shutdown, so many other things. So the cost of shutdown is very high. So they want to measure broad spectrum capable instrument, and whereas in the elevator industry we don't require that much, so they restricted up to 100 hertz only. Even within 100 hertz, our major focus area is around 10 hertz only, less than 10 hertz only. These are all fundamentals to understand. Okay. So next, apart from ISO 2631, this rate quality standard 8100 is formulated using another standard called ISO 8041. This is meant for the construction of the equipment. Any measuring equipment, how the electronic has to be constructed, how the software has to be designed, how the accelerometer resolution and sensitivity, how it should be. So these are the aspects governed by this standard. For example, key points are this accelerometer can capture these signals 0.4 to 100 hertz, it can respond, and filter. The software will be designed for the whole body, some filtering mechanism, and accuracy is there, linear as well as cross axis. Also, we need to calibrate every year. And functions, for example, the normally some peak to peak value and average values used in elevator. In escalator, they use RMS value, root mean square value, all these things. And it has to be stable in temperature wise, humidity wise. And also it is going to work in a vibration environment. We are going to measure the vibration inside the car. So when this equipment itself is going to vibrate, the electronics fixed inside the equipment should not get affected by this vibration, because the purpose is to measure the vibration. So it cannot get damaged because of the vibration. So the integrity of the instrument under vibrating environment, it has to work reliably. That's why it's vibration resistant. So all these things are constructional aspects and frequency response aspect, software design point of view. We know the how much what type of filtering has to be done, and accuracy, linearity. All these things are mentioned in ISO 805141. Any instrument designed for meeting the ISO 8100 has to meet this standard. Otherwise, that is not a standard equipment. So the idea is you have to maintain the calibration accuracy even under external vibration, shock. For example, when you want to measure the vibration under normal condition also, even sometimes safety gear test or emergency, whenever in our India, power supply can fail at any time. When it's going to very high speed, suddenly power supply can fail. So lift will be stopping at very high speed. So it will be very high shock will be there, and temperature can vary, like in Nagpur and all. In summer it can go 50 degree, and Delhi and all, in winter it can go to maybe 4 degrees, 3 degrees. So it has to work under different temperature conditions. Now in our country, but in other areas it may be wider range. So also it should be mechanically robustness, the construction. It should be it has to withstand the vibration occurring in the car or any other wherever it is going to measure. So annual calibration and verification has to be done. So this slide mentions about the another standard, ISO 8041. First one we saw ISO 2631, meant for the frequency response. The second one is more on the constructional aspect of the equipment. So any equipment which is going to be used for measuring, and if you want to measure, want to show it to consultant or a customer, the equipment whatever we are going to use has to meet these standards. The third and final one is the see, when we talk about ride quality, we are talking about not only vibration. Here we are there is a noise level also inside the car. Any sound, abnormal sound also captured, like door movement, or during the travel, any guide rail issues. It can some guide rail joint or any distance between the guide rail is not okay. Some jerk will lateral quacking can come. So it can cause some hitting of some metallic object. It can cause some noise. So that also can affect the perception of the ride quality for the user. He may not like it. So there is a mic provided for such instrument. If you see here, it is used for measuring the noise inside the car during the ride. So that standard is governed by IEC 651. Now it is replaced by 6172. I think more or less same, I think. So these are the three standards which are used, like ISO 2631, ISO 8041, IEC 61672. These three standards are helping to formulate the specification, that requirements for the ISO 8134. So this is the basics about the ride quality. One more item is one more aspect of the construction of the equipment is as per the standard 8041, it has to have a self weight. that equipment, whatever we are going to have, use, it has to have some minimum weight. Why it is required? See, we are measuring the vibration not in absolute level. We are measuring the vibration for the human body response. Basically, when a person is standing on the floor and he is going to feel the vibration through his feet, and his body, say our Indian metric weight for the elevator is 68 kg. This 68 kg is going to be transferred to the floor, car floor. When it transfer the floor, when the equipment, suppose in place of feet we put a equipment. In the equipment, if it is very light, it cannot positively touching or applying the required pressure on the floor. So if it is very too light, for example, one pin, if you take very very small object, if you are exciting with some force, it will vibrate more because it is self weight is very less. Whereas if you are applying very heavy filler weights and all, very thing, so it can vibrate at different frequency. But the measurement method can be accurate only when the body sensitivity is reflected in my measuring equipment. Here, the body is 68 kg is applied over some 200 square centimeter area. 200 square centimeter area it is applied. That means, when you want to have a calculate the pressure, force applied on a area, force divided by area, it's called pressure. So they say that in the standard it has to be minimum 60 kilopascals. If it is this value only, the accuracy of the sensing of the vibration will be correct. Otherwise, it may be misleading. So it has to be necessarily with some self weight. For example, in this type of tool, the PMD tool, the self weight is around 5 kg. To measure, it is intentionally kept in that weight so that it can meet the standards given by the 8041. Now with the latest 8100 also. This instrumentation, the idea is the instrumentation shall remain in stable contact with the floor throughout the measurement process. So sensor has to be stable when it measuring. If it is not stable, it cannot, when it is not having any contact with the floor, it cannot sense the floor. So it has to be stable. So it is an important mechanical condition affecting the accuracy of the vertical vibration. This criteria also important for any instrument that is constructed for this purpose to meet the international standard ISO 18730 or latest ISO 8100 for a measurement of ride quality. So we'll now what we have covered so far about the standards used worldwide. In Indian construct, all these standards are adopted. The standard name is number is IS 17615 1 and 2. There's the equivalent for the ISO 18738 or ISO 8100. Also, a national building code also adopted these standards. So, because it is, we need not reinvent the wheel. Whatever, because some 15-20 years they have adapted. They formulated the standard internationally. They adopted so many escalators and elevator they tested, and they have perfected the standards and the equipment. So, in Indian situation, we have started adopting this international standard, and in this ISO 14665 elevator standard, this ISO 17615 is meant for the ride quality in Bureau of Indian Standards for elevator and escalator, part 1 and part 2. And national building code also adapted. So basically, in Indian situation, nowadays more companies are started following these standards. maybe in the contract they are putting, the consultant they are aware of, they are asking. Idea is to have a proper installed equipment, so that whatever the amount they pay, they get the good quality. Also, the user gets the good right quality. So they nowadays many companies, many consultant are asking these standards. So the awareness is increasing, and this type of session will again international companies are using it last 15 years. Regional companies also started using it. Now the tier 2, tier 3 cities and all, mostly people are not aware or not educated properly. It is for the betterment of the elevator industry. The business side is not a big thing, but it will help to have a, like now automobile cars. We had 30 years ago ambassador car. Now we have so many varieties of car. So with a lot of good comfort level, technology level is different. Likewise, elevator also, those days we were having two-speed elevators. Now with variable voltage, variable frequency and PMSM gearless motors, and the ride quality level is we are able to get excellent ride quality as well as leveling accuracy also. So it is important that each elevator engineer try to use the scientific methods to follow these standards. You get a consistent quality. You can ensure, you can benchmark the best ride quality elevator, and ensure that your subsequent installation you are able to get that. So this is about the ISO IS 17615. So three accelerometer, three axis X Y Z, and my sound is used. My mic is used for measuring the sound. So whatever I have explained. Apart from that, the vibration measurement, peak to peak level and jerk level, velocity, all these things are measured in the standard mentioned. So when I do the analysis, I can talk more about that. Okay. Now we'll come to the terminology side on the standards. Only two slides on the basics. We will define the terminology. We will define the how to make measurement, and processing technique, and defense reporting. Okay. Two slides only, I think. These are the now we have we have covered the basics on the frequency response, how the equipment should be constructed, how the sound equipment, what standard should be followed, and what is the Indian standard, how to why it is important to measure the right quality and all. Now we will discuss about the units of measurement used in the right quality measurement. We will start from the basics. We know the distance we always measure in meters in India, and metric measurement. Velocity, meter per second, or velocity or speed. Elevator speed is meter per second. Acceleration, when you start the elevator or decelerate the elevator, it's called meter per second square. That means rate of change of speed. So one more second in the denominator. That's why it's second square. Vibration also same unit, meter per second squared only, technically speaking. But in a normal contract and our elevator industry, this type of terminology use milli-G or gal. In some customer consultant, they may use gal. Some customer, they use milli-G. But again, it's a meter per second squared only. Jerk is rate of change of acceleration. It is meter per second squared over one more second, meter per second cube. And as I said, sound also we are measuring the decibel with respect to some reference dBA. So this distance in meter, velocity or speed in meter per second, acceleration meter per second squared, vibration meter per second squared, but milli-G or gal. Jerk is meter per second cube, and sound is dBA. So again, in the last one is the milli-G or gal, or the last sentence is meant for that. It both are one and the same. For example, we know 1G, when you have a free fall, and the gravitational attraction, the deceleration rate is 9.81 meter per second squared normally. That is called, it is equivalent to 1000 millig's, 1G equal to. That is equal to 981 gals. Approximately 1000 and 981s are very close to each other. So we can say 1 milli-G is approximately equal to 1 gal. So when you see any contract, gal or milli-G, you can assume both are almost same. So this is the unit of measurement. And how to make measurement in an elevator? See, the elevator right quality measurement equipment, vibration equipment, is kept at the center of the elevator, and it should be pointed towards the door. And you have to have the mic at 1.5 meter per distance, and the mic has to pointed towards the door. This is how you have to place the meter and the mic. And not more than 2 persons are allowed inside the car when you make the measurement. You see, the first point is the conditions are, you got to switch off the any fan or any voice announcement system. Any external noise making equipment has to be switched off. You have to keep the equipment at the measuring equipment at the center of the car. X-axis means front and back. If you see the 3 axes, the front and back is called X-axis. DBG side, guide rail to guide, it's a Y-axis. And Z is the vertical axis. Microphone has to be kept at 1.5 meter. Maximum 2 people are allowed. Why not 3 or 4? Because when the floor has got a strength. If 2 people it's okay, but 3 or 4 people stand, so many 68 kg is going to operate on the floor, then the floor can slightly bend, or it can influence the accuracy of the measurement. The contact area of the equipment can sometimes reduce, because the person inside the elevator, if he keeps on moving his leg, then it is going to affect the floor contact area. So it is advisable to have only 2 people, and not any loose component or object is allowed inside the floor when you make a measurement, like filler weight or any other object, any cleaning equipment or anything should not be kept when you make a measurement. That you will not get an accurate result. And when you make a measurement, it is measured always top to bottom, bottom to top, one full stretch without any stoppage in between. Also, when you make a measurement, you got to include the door vibration and noise also. That means you have to start recording even before door is closing, and you have to stop recording after door is fully opened. So door also, when you say right quality, not only car upward or downward movement, both door movement also to be captured. So that is also important. So you begin recording before door close, finish after door is opened. So this is how you have to make measurement for right quality. So with this, we are covering the basics of the right quality. This slide is about the PMT instrument, which I am dealing with. It's called elevator vibration analyzer, EVAS 625. It is designed based on this standard. This product was launched in 1995, 97 or something. So it is meeting the standards like ISO 2631, ISO 8041, as well as the IEC 651 and all. So it is internationally approved, and most of the companies, almost all companies, are using this equipment only. So 3-axis accelerometer. This is the accelerometer. The SS stainless. This can be removable. So this is an accelerometer, a triaxial accelerometer. Uh, so all these, whatever the standards covers, all these things are mentioned here. And it includes the software, it's a battery operated portable equipment. Also, this is not only for elevator, this is used for escalator also. Escalator, vibration measurement, step vibration, handrail vibration also can be measured using the same equipment. So somebody is buying this instrument, they can use it for elevator and escalator. I have seen in my experience last 15 years, most of the companies, including leading companies, they don't use it for escalator because escalator population was very less 10 years before. Nowadays, only last 6, 7, 8 years, it is increasing. Now, I think 4 companies are having a factory, escalator factory, like Johnson Elevator, Otis in Bangalore, and I think Schindler in Mumbai, and other people they get in semi-knocked up condition, they assemble it, I think. So escalator population is now, but a lot of metro and shopping mall they are having these. Maybe in my opinion, it can be more than 5,000, 10,000 escalator. I'm not very sure. So, but I have never seen people are using this instrument for escalator ride quality measurement. The idea of this session is to encourage people to use, because when you travel in a shopping mall or a metro or in a airport, you can see when you keep the hand in a handrail or step, some equipment vibrates more. Also, I have seen in Dubai also, not only here. So the importance for ride quality during the usage, as I said, even in elevator also, at the end of commissioning, we are checking it, not during the maintenance side. Likewise, escalator also, maybe during the after completing the installation, they may be checking it, not subsequently. It is important because it helps in preventive maintenance. See, it is like a ECG for a human body. If you get a reading where you can, if in the initial stage you will get a better reading. After 6 months or 1 year, you may get a poor reading. It may be because of some rotating element or wear and tear element has deteriorated and causing this vibration. So if it is, when it is very minor level, that time itself we can attack the problem. That's the idea. So this equipment is for escalator also. Also, this equipment, this accelerometer can be removed. For escalator, step skirt gap, normally we keep 4 mm gap. On either side, put together 7 mm gap as per the Indian IEC standard, I think. So that gap can be measured using equipment called IMD that can be connected with this equipment, as well as the handrail speed and step speed can be measured, and escalator stopping distance, which is a safety. Both the steps skirt gap and tacho speed measurement involves safety checking. So this instrument is a common instrument used for this. But one more thing is when you want to measure a vibration during the safety gear test, when high speed tripping, this instrument accelerometer can measure up to 2G only. So if you want to measure more than 2G, like in a safety gear situation, I don't know the controlled deceleration, maybe I don't know how many there, but we have seen in my days I have seen 6, 7G and all. So the nowadays many companies are buying one more special accessories available with the PMD. It's called 10G accelerometer. I will show the catalog in the last. So this can be removed and put a 10G accelerometer in place of that, and you can make measurement during safety gear activation or emergency stop situation, high speed tripping situation, because that is very dangerous. Sometimes the any object can fall, or inside people can jump and hit the roof, depending on the type of level of thing. I don't know if the new design in elevators for such situation they have reduced the speed. I don't know. I mean, controlled deceleration. They are doing it. I don't know, but The 10G accelerometer is used by many companies. That is also one optional accessory available. And now latest development in this is a Bluetooth type. We are having the same instrument for analysis. We have to use a laptop previously. Now we can use an Android mobile itself. You will get all the readings for elevator and escalator. And Android mobile itself is sufficient to record the reading as well as analyze the reading and send the reading to our top officials. So it's very convenient. One is the latest model. We are supplying both models. Whichever is convenient for the customer, they can purchase. Both are same price only. And existing old, see the EVA meter, the EVA 625 used normally up to 10 years easily, sometimes up to 12 years, 13 years. Beyond 15 years, we don't recommend because the reliability of the equipment, sometimes depending on the time maintenance methods and other thing usage, can deteriorate. So it's a because equipment is a high accurate equipment. Beyond 15 years, it's better to look for a replacement. Less than 10 years old, we can convert the existing pen drive model to the Bluetooth type, so that mobile itself can be used. Okay, I think I will go to the analysis session. I am running behind the schedule. Okay. Now I will start another slide about the analysis. Sija, you are seeing the blue color?
Yes, yes, sir.
Okay, ma'am. Next, okay, this is about the right quality measurement. We have seen how to make measurement. After making measurement, how to see the reading and analyze the reading, I will explain you firstly. See, you will get this type of graph. You can analyze in laptop or mobile. You see the first slot. Now we are seeing the sound measurement. Maximum sound is 71 dB. Average is around 61 dB. In the same slot, you can see the distance also. Travel distance of the elevator, maximum 34.8. That you can check. Third option is the velocity or speed. Here in this case, geared elevator is 1.65 meter per second squared, 1 meter per second. This is acceleration, high speed and deceleration. Acceleration you can measure. It is acceleration. This one is a deceleration. Acceleration 0.9, deceleration is minus 1. And jerk also you can see jerk, maximum jerk at the starting and stopping jerk. These are the first slot. You can, 5 parameters you can see: sound, distance, velocity, acceleration, jerk. Next one is the vibration level, horizontal vibration and vertical vibration. Horizontal vibration, if you see ISO, see, normally I told you we are capturing up to 100 hertz. Now whatever you are seeing the 100 hertz frequency vibration, 2 types of values are captured. Maximum peak to peak are measured, and average A95 means 95% of the time what is the value, that is what is the bandwidth. So it is about 22. So maximum peak to peak is 53. So this is on the raw side. This is on the front and back. Blue color, this one is X1 is the front and back vibration. So next one is the Y, guide rail side, sideway, guide rail to guide rail movement, lateral quacking or something. Here if you see, peak to peak is 55. For example, here it is milli-G. Vibration is here it is average value is 24.9. And vertical vibration is very high. It is 102 milli-G. Average is 71.8. I told you this is up to 100 hertz. But as per the standards, We are not interested more than some frequency. I told you in the frequency graph, beyond 10 hertz, the body response will be poor. So we are like when you want to solve a problem, 80-20 principle, like 80% of the time, how much is there? Maybe less than 10 hertz, that is going to cause the high sensitivity of the body. So what there is a filter. I told you, no, the in construction of the equipment, there is a software filter which can filter out beyond 10 hertz. It's called ISO filter because as per the standard, they are asking to knock off the frequency beyond 10 hertz and see the performance. Because when you, for R&D purpose, you can analyze using this graph. For when you want to prove to customer or prove to consultant, this will give a worst scenario. But this is not to be need not be shown. This is not. But as per the recommendation, the ISO filtered value is when you put a there is a unit setting is there. When you unit setting, if you see ISO setting set, it is 10 hertz. But you can change. Sometimes some companies, they for R&D purpose, they can change the frequency, cutoff frequency. But ISO, it is mentioned in 10 hertz only. So 10 hertz ISO. So when you put ISO, see all the unwanted frequency beyond 10 hertz are knocked off. It looks more simple. And if you see the peak to peak, it is now reduced. Earlier it was 53, now it is 7.8. Average value also reduced. Again, and get 10.2 and 5.7. But still, vertical vibration is very high, 43. And average value 33. See, standards always defines what are the method, what are the units to be measured, how the equipment is to be constructed, how to make measurement. All these things are covered in standard, but they are not advising or recommending what is acceptable level. All along, I have seen even in old standard, new standard, they don't recommend any particular value. This is good or this is better or this is best. They are not saying. It is up to the customer or a consultant and the supplier. They can agree upon a particular level. But what I have seen in many companies, they follow internal quality levels, and the peak to peak level in X and Y and Z, they will try to get around 15 millig or 15 gal, less than 15 gal or something. So beyond that, if you are even with the, today's technology, you can get less than 10G easily. This is for this equipment measurement done in 1995. That time itself, the geared equipment, it is 7.8 and 10.2. Now you can measure in your geared equipment if it is there. Now mostly gearless also. Gearless mean much more smoother ride you can get, and this value can still better. And vertical vibration also, depending on the hoisting inflation accuracy and machinery condition, you can better get a better this thing. So how to use this graph? For example, horizontal vibration. This vibration, if you want to reduce to get a better ride quality, you have to identify the problem area and eliminate the problem. In this case, for example, the front and back vibration, you see this position, some cross is there. This is mean the 7.8, though it is acceptable now. Suppose you get some 15. This is the place you are having a problem. This problem can be located in the shaft using this graph. How? You just put your distance curve here, and you go take the mouse cursor here, hand symbol, you make a click, and you see the cross section point. You see the measurement here. I don't know whether it's visible for you. It is 27.68 meter. That means when it travels from 0 to 27.68 meter, at that point there is some problem in the shaft. It may be some guide rail joint, or it may be guide twist, or DBG, the distance between the guide rail is not kept correctly. That may be. So you can go and check this point exactly and see what type of problem and correct it. If you correct it and again you take a reading, this jump will not be there. So, if you take the reading in a raw sense, here it is not shown. Okay. So, this is the method of solving the horizontal vibration problem when a problem is impulsive, it will localized problem. When it's a particular position, you are getting a issue because of the wrong installation. So you can solve this problem. Likewise, with the y direction, guide rail to guide rail, again here you can put a cursor and 24.45. At this point, if you check, there could be some issue, you can solve. So horizontal vibration fairly easy. Mostly it will be a localized problem. Only when you use a roller guide shoe, and sometimes the vibration, because some roller guide shoe is there, that vibration may be continuous here. If it is continuous, then there is some other method you have to use to solve the problem. But such type of lifted very rare. Only the vertical vibration situations are many times you can face that problem. So horizontal vibration, this is the method. So we have to focus on the maximum peak to peak only. Customer or consultant, he'll be worried on the maximum peak to peak value. It should be less than 10 or 15, in my opinion. Whereas the A95, A95 is nothing but you can zoom it basically. A95 is, you see so many oscillations. The peak to peak means here from this point to this point. So many oscillations means 95% of the oscillations are within some limit. It's called A95. So, the two parameters, maximum peak to peak and A95, are looked at it and you try to solve the problem. Z direction, vertical vibration is slightly, I don't know, we have time. It's a slightly complicated, but I will explain briefly. This vertical vibration, so here if you see it's a 43, it should be less than 15 or 10. How to solve that problem? You can, there is a method called FFT, fast Fourier transform. Uh, this is, that means basically, you know, in an elevator, there is a rope which can cause a vertical vibration problem. There is a rotating element like motor, or gear or a sheave, or diverter, or roller guide shoe. All these rotating element also can cause problems. So it's like a rule of elimination. If you want to solve the vertical problem, first we have to sort out whether it's due to a rope or due to any rotating element. First, we let us rule out the rope related issue. How to rule out the whether it's identify whether it's a problem is related to rope? Simple thing is, there is a concept called, when the rope length varies, the frequency will also vary. For example, if you take a normal day-to-day life example, if you have a guitar, there is a guitar string, and when you strike and you get some music, when you reduce the distance using left hand, people are, when they play, they will put the hand in different places. Idea is to, they want to reduce the or vary the length of the string. When you vary the length of the string and strike it, the music will be different, the pitch will be different. So that means that when the length varies, the pitch varies. That means the frequency varies. That is the principle is taken in solving a rope problem in an elevator also. When the lift is in the ground floor, the rope is tied on the car top, and other end is tied to the main sheave. For example, in a single one is to one roping. So when the lift moves from bottommost floor to topmost floor, the length between this car top and the sheave keeps on reducing. So when you nearer goes beyond mid floor or go near the floor or topmost floor, the length is going to be very less. So the rope frequency, ignite that oscillating frequency when they're reducing the length, the oscillating frequency is going to reduce. So you can by hand also you can feel when we are closer to the topmost floor, very difficult to pull the rope. So the idea is when the rope length is varies, frequency is varying. So the FFT method is it's called fast Fourier transform. Fast Fourier transform means you are going to identify different frequencies in a vibration, which frequency is causing the maximum problem. I'll do it for a particular. See, this is the velocity curve. So here, for example, we are taking at this high speed point. This is the acceleration, end of acceleration. High speed point. Here you start for a particular area we are taking and trying to analyze. So FFT, you can Z. We are doing FFT on the Z axis. We take a snapshot of 4 seconds interval and we will check. So you will get this type of graph. This is called, previous one is called the time versus amplitude. This one is the frequency versus amplitude. So the frequency method of analysis. Here from this one is 0 to 130 hertz, 100 hertz maximum. And this is the milli is the amplitude. Basically what it does, it does try to identify which component is making the more vibration. See, if you see here, in this case, this is the highest one, and there are some higher level vibration also. This frequency, you see, it will be like 4.5 hertz or something, and this one is some level, and this one is around 25.75, and this one is around 52. So this this particular item which is rotating at 25 hertz. See, any rotating element, it is evolution per second is called a frequency. So for example, you have a 200 rpm gearless motor, 200 revolution per minute, per second means again maybe 2.5 or 3 revolution per second. It's a 3 hertz basically. So gearless PMSM motor, it will be in the order of 3 hertz. For example, when you take here, for example, there is a calculator. You can put the RPM and you get the frequency here. So, for example, a geared motor, 1500 RPM means 25 hertz. If you put 1350 RPM, you will get the corresponding rotating frequency, 22.5. In this particular case, example, 1500 RPM motor, I think, it is around 25 hertz. It's closer to the motor related issue. But this is only one snapshot. Next, we will see some closer to the mid floor. Again, do for again 4 seconds. And you see other vibrations are reduced. Only the 25.75 hertz vibration is increasing. Now 3.9. Previous amplitude was less. So that means the second position also, some object which is rotating at 25.7 case, in this case around the motor, it is causing the maximum vibration. And we'll go near the mid floor and take again FFT analysis. In this case also, if you see earlier it was 3 amplitude, now it's 7.5, but same frequency. Now we are, because if we see go to the topmost floor, the frequency that we see that vibration level is very much higher. So again, closer to the topmost floor, we are going to see. Here it's previous was 7, now it's 12. It's 25.75 hertz. So it is the frequency in all 4 instants, almost 5 instants, remains same. That means what? The frequency, the vibration frequency is not varying much. The whichever object is causing the maximum vibration for the human body sensitivity, that is, the frequency remains constant. It is not varying. If it is not varying, that means we can conclude it's not due to rho. Then if it is not varying, it's remain constant, then it is one of the rotating element like motor, gearbox or sheave or a roller guide shoe. That you can find out which one is, for example, main shoe. It's 450 dia. The frequency is only 1.2 hertz. Secondary shoe 1.3 hertz. Lower gates 125 it's only 4 hertz. So in this case, we are getting 25 hertz. It's more likely that it is related to the motor or gearbox, because gear is also connected to this. It could be so that we can suspect the vertical vibration problem can be solved by checking at the motor. Now there is one more level of testing where we are checking inside the car. Now you take the EVA meter, remove the accelerometer, keep the accelerometer on car top, that machine body near the gearbox, and try to run the elevator, make the right quality reading like this, and do the FFT analysis there. There also we get the 25 hertz. That means gearbox is the problem. You can solve the problem. This is how we solve the horizontal and vertical vibration problem in an elevator. In escalator also similar method, step and handrail speed we can measure. In step, when you measure, see escalator unlike elevator, it is on an inclined level. So mainly the axis vibration, x-axis will have more vibration. Other axis y and z will not be that much. So yeah, handrail vibration also like that only. So only method of measurement is in step speed, step vibration measurement. You keep the EVA meter or anything on the step, and do not put the feet underneath in an escalator, because it can get stuck. No need. Whereas again run full run for the escalator, and make measurement like this, and do the ISO filtering, and check the maximum peak to peak, and I can show the on escalator reading also. And other one is the handrail speed. I told you, I showed you the accelerometer can be removed, and there is an extension cable we are giving. The accelerometer can be kept on the handrail, and you go along with the escalator. You run the escalator, you also travel, keep the accelerometer on top of the handrail, and you can make measurement of the speed. So this is about the escalator vibration measurement. In escalator, two other measurement what we do, I will show the catalog and explain you. You are seeing one slide called IMD.
Yes, sir.
Okay. So this equipment used in escalator, it is called index measuring device. In Indian situation, this is meant for measuring the gap between the skirt and the step. Normally it is kept at 4 mm. In a EN, forgot the standard name, EN standard. So that is a measurement is a 4 mm on both sides put together, 7 mm you keep. Why this gap is to be kept at the, because when you travel in the escalator, somebody put the foot here, the either cloth or a finger can get captured, and it can cause injury, and equipment will also get damaged. So that has to be kept at minimum 4 mm. The idea of one brush also, normally deflector kept for the escalator. You can see one brush along the escalator that is meant for concealing the gap. But Indian situation in Bangalore and all, I was told people are using it for polishing their shoes. Because of that, many times the shoes or chappal or anything gets caught inside the gap, and either injury or the step is getting damaged. So deflector is meant for hiding the gap, so that to prevent the people to put anything on inside. So the problem is the whatever the standard we are following here, we are making only static measurement. Normally, escalator it is because the recommendation is only static measurement. When you measure by shims or something, they keep and make the static measurement. That means when the escalator is not running, they make the measurement. But practical situation, when the escalator is running, you can see the gap is will be widening because the escalator step can move on one side and the gap will be widening because people may be standing, it will be sliding at the other's opposite side. It may be some 7 8 mm it can move that side. So that may be causing entrapment possibilities there. So running condition we are not measuring. This product is designed as per the escalator was is used in US and all for more than 30 40 years, I think, maybe, I don't know. So because of that, the accident possibility was very high in US, Australia and all. So they designed this product to prevent the entrapment in when escalator is running condition. So this equipment, what it does, it's like you are making a measurement of the gap. It's called loaded gap because when people are standing, the gap is going to widen because when nobody is there, the gap will be less. So ideally, you have to measure when something is loaded. So it's a loaded step and step skirt gap is measured. Also, the coefficient of friction of the skirt, because once something is going inside, for example, on cloth, if the friction of the skirt, if it's too high, it can pull more. So the injury or entrapment possibility or injury level will be more, the coefficient of friction is more. So both these two aspects are measured using this equipment. It is called step skirt performance index. And this type of graph we get, I don't know whether you are able to see. Because time is very short, I cannot show this. So loaded gap, you see all we make 4 measurements. Right hand side, one you take one step, right hand side and next left hand side. Then you take 8th step and take one right hand side and left hand side. So that it covers the entire area, entire steps. So all 4 steps, if you see here, the measurement loaded gap is measurement some loaded gap in inch. It is shown in inches. So here different inches for the different sides, and this one is the coefficient of friction, 0.142 to 0.215, 0.182 like that. And there is a formula. They arrived the empirical formula to avoid the entrapment. The basis of the formula I don't know, but this is the formula. With this formula, we can arrive the index using the coefficient of friction and loaded gap. So that called step skirt performance index. The criteria is if the index is less than 0.25, the entrapment possibility is very less. If it is 0.25, more than 0.25, there is high chance. If it is more than 0.15. But when you have a deflector, there is some relaxation allowed. Up to 0.25 is allowed. But in Indian situation, even if a deflector is there, people are putting their foot, means it is better to keep the criteria as 0.15. If it is more than 0.15, that means the step has to be adjusted and escalator. So during the usage only, it is going to, the gap has to be, is going to change over a period of time. So it is important that the gap and coefficient of friction are measured using this type of device. Some leading companies are already using, some metro, Delhi Metro, and some metro projects they are using, because it is standard. Following standard is one level. If you are more bothered of the safety, it is not about the qualitative aspect, it is more on the safety of the user. So they, for safety, you have to, for the public safety, you have to have a better stringent checking mechanism. So it is American standard used here, but nevertheless India and many companies are using, even for escalator factory also they use this type of device. There is one more escalator tool. I hope you are seeing this EWAT 625 ETCH01 tachometer module. Are you able to see, Shida?
Yes, it is visible.
Okay, this is called.
Selvam sir, is this the last page? Because we would be having more 4 to 3 minutes. If we have 2 questions, if we would like to answer those questions,
Okay.
or there are more pages here.
No, only one more product I have to show, 1 or 2 products. I will just
Okay,
quickly,
okay. Please go ahead. Please go ahead,
within
sir.
3-4
Okay.
minutes, I will complete it.
Okay.
Okay, this is a tachometer used for measuring the handrail speed and step speed. This is also used along with the PMT tool. So maybe for individual, whoever is having more interest, they can get in touch with me later, and I can try to provide more information. So the another product is called just 1 minute each. This one is called a drive test door closing force measurement. As per EN 81 standard, we have to measure the closing force. It should be less than 150 newtons maximum. So this instrument, it's a load cell based electronic instrument. The Bluetooth type also is in the old type. Bluetooth is also available. Basically, it is measuring the when the door is closing, what is the maximum force allowed, and the energy allowed is defined in EN 81. So it should be less than 150 newtons and joules less than 10 joules during the normal, and nudging less than 4 joules. So that is there is an electronic like EVA. There is a graph you can get, and I can show this type of peak force, uh, average force, everything you can measure. It's a German. This equipment I am selling last 5-6 years. Is not only used in elevator. I am selling to automobile. Say I am representing. I am selling some equipment automobile industry also. They also for car sunroof, power windows. The force measurement is important. You will get this type of table, the maximum force and average force, that the pulse duration of the door movement, and what is the speed of the door. All these things you can get. So it should be less than 150, indicates around 300. Normally during the usage, the speed can increase because of wear and tear of the roller. So the force will be very high. I have seen in Dubai and all. I have measured in some metro also, more than 300 newtons are there. It is because the people will be running. The last moment try to enter it. The normal condition. See, if the sometimes some people say the light curtain is there, it will open. Light curtain, there is a blind area, and when the door is closing, maybe in the 100 mm, the light curtain cannot work. I think elevator engineers can say better. So that area, if you put a hand, it cannot open. So then it can cause injury if it is more than 450 newtons. It's only at chance only. Okay. Last one is the rope tension gauge. This one last 10 years I am supplying. This is called a rope tension gauge. Is more of a not an electronic one, mechanical one for adjusting the rope tension so that all ropes are in equal tension. It will help in to reduce the wear and tear of the uneven wear and tear of the rope, as well as improve the safety, because uneven wear and tear is there. It can the rope can get cut, and also ride quality can improve. So this type of any tool you can use. This is a cost-effective ruggedized tool. I have sold many. TK Elevator is our major customer, and as well as Fuge Tech, Johnson Elevator. So many other companies are using more than 300 numbers, even in Dubai also. It's a ruggedized, more on comparative principle. First, you take 2 ropes and compare, and say make 2 ropes equal, and that type of principle. So, so these are the I think I covered the basics of the ride quality, standards, how to measure the ride quality, how to interpret the ride quality, how to make measurement in escalator, and few products meant for improving the safety in escalator as well as the elevator door safety and rope tension gauge. Normally, I take 2 hours. Here it's 1.5 hours. That's why I have to cut short some. But mostly I have given some overview. I think. Hope. Thank you so much for the opportunity for the ISE Ventus for sharing my knowledge. Thank you, Shida. Thanks
You're
to Mr.
welcome, welcome,
Matthew.
Selvam sir.
Thanks to
Yes.
Matthews. I can wait for any question raised by
Yes, there
members.
is one question from
Yeah.
Mr. RL Birla who's asking why the vibration in the graphs is specified as dB in vertical axis for both horizontal and vertical vibrations. dB is a unit of noise. Please clarify.
Vertical vibration, I explained the unit of measurement is milli-G and gal. Uh, uh, we have not mentioned anything dB. dB I mentioned for the sound measurement. So mic measurement, maybe what you can do, you can share my number to him. I can suppose he is not get clarified. This point, over phone I can clarify it.
Email ID with you.
Yeah, that's okay.
Yeah, and we have next question from Mr. Nandakumar. Is there any specific standard for routine maintenance checks for elevators?
Yeah, basically routine check from the ride quality point of view. This method you can follow. For example, when you first time when they hand over the elevator after 1 month of usage, when the rope stretch everything is over, doors are very smooth, when dust and all not there, then you make a measurement and that can be taken as a reference benchmark. After 6 months, you make measurement and including the noise. Door is the most abused item. You get noise as well as vibration. When you compare, definitely there will be a deterioration. Then specifically that engineer can look at it how to solve that problem. The periodically every 6 months or 1 year they can do it depending on the usage. Some lifts are used very rarely, sometimes very frequently. Depending on the usage, you can decide the periodicity. Thank you. Anything else is there? No audio. No, Shida, audio, please.
Ashutosh, yes, sir. I
Yeah.
mute was
Yeah.
on. Ashutosh Kumar is asking, what is the role of MOE in a rope for elevator purpose and why line marking is important in an elevator rope?
No, I am not very familiar with the elevator roping mechanism, but I have seen line marking meant for a twist to avoid the twist. See, if rope twist is there, then it can cause vibration in the elevator. I have seen in rope used in abroad in a document here. They do a red color marking along the rope so that when they lay the rope, they will not have a chance to rotate it. Whereas in I think Usha Martin, I don't know whether it is there in Indian ropes. If it is not there, based on the experience, they can decide. But there is a high chance for rope twist because we are not measuring the right quality. Twist is not an issue. So, but wear and tear may be high. But maybe the marker is meant for avoiding the twist. I think I am not the expert of roping. So this is the knowledge I have. Okay, just okay. Thank you.
Okay, 1 second. Ashok Kumar is again asking, IS lubrication percentage critical in elevator rope? So I think you already answered that question. Then Mr. Rupesh Patangi is asking, what is the standard parameter we have to put in PMT machine?
Uh, the standard the units setting I have told. See, basically I have explained no that velocity meter per second, distance meter, acceleration meter per second squared, vibration either milli-G or gal you can prefer. Jerk is meter per second cube. These are the units you mention in there is a setting for units. You can define that setting there. Otherwise, when you do a analysis, FFD analysis, you can select duration, and there are some options available. For the higher level analysis, there are so many options. This equipment is not only a checking tool, this is more on a checking plus diagnostic tool for R&D purpose also. So there are, like for example, samples per second, 256 samples there, 512 samples per second is there. So maybe normally we use 250 samples per second, that is good enough. Whereas maybe R&D purpose, you can do 512 samples per second. So depending on your type of, purpose, you can use the equipment accordingly. These are the various units used.
Okay, he was actually asking in figure, sir. So is there any
Figure.
particular?
No,
Yeah.
no, basically, okay, in figures, okay, speed is depending on the site condition. Acceleration level, there is a comfortable acceleration level. Normally, in my experience, I have seen 0.75 meter per second squared to 1.25 meter per second squared. Beyond that, if you increase, it may not be so much comfortable. So for example, if you have a 2.5 meter per second or 2 meter per second, 1 meter per second squared acceleration you can keep. Likewise, deceleration also. If it is 5 meter per second, 1.25 you can keep. So maximum 1.25, that is comfortable. Beyond that, you should not increase. Less than 0.75, you should not keep, because it will reduce the efficiency of the elevator. Suppose you have group of elevator, 3 elevators. If you slow down the acceleration, the transport, there is a parameter called transportation capacity of an elevator. How the throughput, the peak time handling of the elevator. So the throughput will get reduced. So acceleration. And regarding the jerk, normally it's a 2, maximum, normally 1.5 meter per second cube, maximum 2 is generally used. These are all industry standard. There is no acceptable level or something. As I said, X and X, Y, Z, all horizontal vibration, both horizontal you can be very strict, less than 10 for gearless elevator, less than 10, gearless means around 12 or 13 like that. There's a vertical vibration, less than 10 or 12, maximum 15 for geared elevator. So these are the various accept figures for the different parameters.
Okay. Is the vibration in elevators having any impact on the rope length variation?
Rope, see, if there is a vibration, rope can jump. If the vibration is not kept properly, sometimes it depends. See, rope tension is not okay, it can jump. So it's a both. It is compound each other, vibration and rope tension. So both has to be adjusted properly. That's what I like to say.
Okay. So I do not see any more questions here. One second. Ashutosh sir, is there any new development in elevator ropes with plasticated ropes usage?
It is beyond my scope. But, I mean, the rubber, people are using now belt type rope in many companies, OTs, and in many gearless elevator they use rubber type. For
Okay.
at least for the low speed, high speed they still use a stainless steel rope. For many companies nowadays use a belt type only, gearless for PMSM motor. Other than that, we mean plastic means that only, I think. Maybe it's a polypropylene or something. The material,
Okay.
that material, it's a polypropylene type, I think.
Excuse me.
So,
Okay.
yeah, I think he meant that. It is used, it is depending on the design. So each and every Kone, I think the Otis, Gen, and other companies, they are using, a lot of companies are using belt type.
Correct. Correct.
Hmm.
No, it is HDPE sheeting over steel wire rope.
High density polyethylene.
No, he's writing no, it is HDPE
Ah.
sheeting over steel wire rope.
Okay, I don't know. I mean, this session is more on the ride quality. So I was working till 2009 in elevator industry. After that, practically my exposure is very limited. like this type of session I come across this, so I cannot answer that question.
No problem, sir.
Mm.
Okay, so it was a really amazing, informative session, sir, with all the slides and presentation which you made. I really thank you for your time that you removed for it, and we made a very successful presentation as well. And I hope to see you soon again. And just to all the viewers and attendees, that please note that every Tuesday we do take these sessions through our exhibitors. Next Tuesday we will be having a session by Tektronix. Mr. Milind Shingate will be taking the session. I'll be soon sharing the details. And thank you, Selvam sir, for your precious time.
Thank you.
And thank you for being
Thanks
there.
to all participants. Thanks to Shita, and thanks to ISA Ventus and Tak Matthews and Priyanka. And
Yes.
this is an opportunity to share my knowledge as well as get to know some area. Spreading the right quality knowledge is important from the industry point of view also. So once again, thank you everyone for the opportunity given.
Yes.
Hope it was useful. Hope it was to a somewhat better than 1 hour before. You may have some knowledge. After 1.5 hours, some you have better equipped slightly. So
Correct.
always, I mean, if there is any specific clarification, you can get my email ID and correspond with me. I am ready to support
Sure. If anybody would need any information, they can get in touch with me. My number is 9082731535. So, if in case if somebody wants to get any kind of a contact, they can get in touch with me.
you. Also, in website, if you go in search for my company name, you can find the mail ID also.
Sure. 1 second. I'm just answering one, Mr. Ronald D'Souza, that he's asking can to get the recording of the session. So I will just share my number with him, and I will give him the details.
See, apart from this, you just go into YouTube. Our President Greg has published some YouTube, same thing, whatever I explained in his language, in much more elaborate manner, he has explained. So if you go to the YouTube, seek for PMT EVA 625 related
Correct.
thing, you will get much more knowledge on this. So that is another
Okay.
source of knowledge.
Okay. Thank you, Selvam sir, and
Thank
you
you.
do have a very pleasant evening today.
Thank you so much.
Thank you.
We are having a
See you.
rainy
Thank
day
you.
in Chennai.
Thank you. Thank you, sir.
Thank you.
Bye-bye.
Bye-bye.